We're going to continue with some more algorithmic composition techniques. The first of these is random walk, sometimes called drunken walk. The question is, what kinds of pitches create interesting melody? If we just use uniform random distributions where all pitches are equally likely over some range, we tend to have very large intervals. Let's listen to that. So in practice, smaller intervals are more typical than large intervals. So if we can give higher weight to those, we might find something that's more pleasing. We can do that in a number of different ways. Here's an example at the bottom of the slide using make random, and we're just using that to pick random numbers, and we've actually by hand sort of put in a large set of intervals where repetition, the interval 0, is pretty uncommon. Taking a half step down or a whole step down is more likely. Larger intervals of a minor third, major third become diminishingly small, nothing larger than a tritone going down. And similarly, we have sort of a balance of upward intervals with very few large ones. Then we're using make accumulate to sum up these intervals, starting at 57, and this generates the example you just heard. Another technique for algorithmic composition that's very commonly used is the Markov process or Markov algorithm, where we think of music, or really any process, as a sequence of states, and there's some probability of going from one state to another state, and these, in fact, the probability of being in a state only depends on the probability of being in the previous state. At least when you do that, that's called a first order Markov model. And you can also build Markov models where the next state depends on the previous two states, and that's called a second order model, and so on. There are some code examples available. I just want to play something that was generated by a Markov model as an example. And finally, let's talk about rhythmic pattern generation. There are many, many techniques. We've seen some already, but here's one technique that you might like to try. It's you generate a sequence length from some probability distribution, or maybe it's a fixed value, or it's your choice, and then you generate a random number with that number of bits. So if the length is n, then we need to pick a random integer from 0 to 2 to the n minus 1, and then you translate the bits of that random number from where 0 is a rest and 1 means play an event. So here's a function to do that. In this one, actually, instead of generating a random integer, we're just generating a sequence of random zeros and ones, which is equivalent. And we're using make cycle to play this pattern. So what will happen is we generate the pattern with this list calling random many times, and then we're going to repeat that pattern. And it's not generating the random rhythms that actually produces the rhythm. It's generating the cycle and repeating it that's really important, because your ear will pick up the repetition and turn it into a rhythmic sense of rhythm. over here, I've made 3 instances of this rhythm pattern demo and played them on different resonant frequencies. So we have sort of a trio of random rhythms playing at the same time.